Good morning, children. Today I am going to continue the lesson along with motion. In the previous class, we saw three types of motion, isn't it? Which were they? Rotation, circular motion and linear motion. So we saw that if an object turns on its axis, that is called as rotation. When an object moves in a circular path, it is called as circular motion, and when an object moves in a straight line, that is called as linear motion. Now today we are going to learn another type of motion. For that, please observe these two videos. In the first video, you can see a pot is dangling, isn't it? It is moving that side and this side. Did you observe? The next one, you can see the wiper of the car is moving to and fro. Can you take out any other examples like that? We have seen, isn't it? The pendulum of the clock. Okay, you can see here the pendulum of the clock is moving up and down, to and fro. I have one more thing in my hand. That is, can you see this ball here? This ball we have been using for the other three also. So with the same ball, I am going to show you. So it is, I have tied it on a piece of thread. So it is hanging like this. Now I am taking up till here and I am moving it. So it is moving to and fro. And look at the point here. It is fixed on a particular point here and it is moving to and fro. One push I gave and it keeps moving, isn't it? Till that force is stopped, it keeps moving. So this is another type of movement, and this type of movement is called as oscillation. So what is oscillation? When an object moves to and fro on a particular point, along a particular point, that movement is called as oscillation. Okay? So, what is oscillation? The to and fro movement of an object along a particular point is called as oscillation. Okay? Now, you have seen the movement of this ball and you have seen the movement of the wiper of the vehicle. Are both the movements oscillation? Yes, we can say it is oscillation, isn't it? Because the wiper is also moving to and fro and the ball is also moving to and fro. But there is a difference in that, isn't it? What is the difference there? Here, it is already hanging. I just took and gave a push and it keeps on moving without any other force applied till that force of the push which I gave is over. It continues moving, isn't it? But what is the difference between this and the wiper of the car? There is a difference. Yes, we know that the wiper of the car is not moving with the first force which is applied, isn't it? It is moving because there is a motor inside it, isn't it? It is a machine. So, if we put off the switch, it will stop there, then and there. But this oscillation doesn't stop like that. We have to apply force to stop. Okay, there if you put off the switch, it will stop. So there are two types of oscillation. This oscillation is called as free oscillation, and the oscillation of the wiper of the car is called as forced oscillation. We are making the wiper to keep on moving. What is the difference here? This ball stops moving when the force applied is automatically stopping, isn't it? But the car is not like that. The wiper is not like that. Immediately if you put off, it will stop then and there. If it is in the center, it will stop there. So that type of oscillation is called as forced oscillation, and this oscillation is called as free oscillation. Because suppose we hang it and a wind blows, that is enough for this ball to oscillate. Okay, where the pot is hanging outside, a breeze is enough for the pot to start hanging. And then you have many other items at home which oscillates. That is a hanging lamp, isn't it? A hanging lamp. If a breeze comes, it will start oscillating. A swing, that is the first example for oscillation. We all like to go on a swing, isn't it? So if you give a first push, then even if nobody pushes, it will keep on going up and down till that force applied is automatically stopped. So all these are examples for free oscillation. Okay. So we learned oscillation here. Now I am going to show you another thing. This is a steel scale, isn't it? Please try to do this activity at home. Okay. Can you see something here? Yes, we can see that the scale is vibrating, isn't it? See, we can see that the scale is vibrating. Can you see the vibration there? Yes. If you keep your hand here, you can feel the vibration, isn't it? So this type of movement is called as vibration. Now what is this vibration? Look here. I am keeping the scale here and doing like this. So here we can see the scale is going up and down, to and fro, isn't it? So what is this? What is this? This is oscillation. When I am doing like this, the scale is going up and down. So this is oscillation. Now I am keeping it here and doing like this, isn't it? That time it is moving very fast. The same thing which is happening here is happening here also. But when it is moving very fast. So this fast movement we called it as vibration, and the slow movement here is oscillation. So here it is vibrating, isn't it? Here in the scale, experiment of the scale, we saw that when I was moving the scale slow, it was going like this, isn't it? When I was moving the scale fast, you could see it vibrating. So what is vibration? Here we see that both the movements, oscillation and vibration, can be seen on the steel scale. Okay. At home also, keep it on a table and do and see. You can do this experiment at home. So here we saw when you're moving it slow, it is oscillation. It is going up and down. When you're moving fast, we cannot see that oscillation. That is called as vibration. So what is vibration? Vibration is very fast oscillation. Vibration is very fast oscillation. So vibration, we cannot see the oscillation happening there because it is very, very fast. Okay. So we learned what is oscillation. The to and fro movement of an object about a point, mean point, is called as oscillation. And what is vibration? Vibration is very, very fast oscillation. Is it clear? One more experiment. I can now, when we were doing with the scale, vibrating with the scale, we heard something, isn't it? Yes, we heard a sound coming out. We heard a sound coming out. So for example, we are talking, isn't it? When we are talking, from where is the sound coming? From inside our throat. So when we are talking, if you keep your hand here, isn't it, here, we have something called as the vocal cord. Okay, we have something called as a vocal cord. What happens when we are talking? When we are talking, the air is entering inside. This vocal cord inside is vibrating, and that is why we can hear the sound. So how is sound produced? Sound is produced when vibration takes place. When vibration takes place, sound is produced. So what is sound? In the air. This you have to learn in the higher classes. We are not learning that in our class. But when you go to the higher class, you have to learn. That is why I am mentioning here. In the air, we have lot of waves, sound waves. So when the sound waves are vibrated, sound is produced. The same way, when you are talking, if you touch here on your throat, you can feel a vibration here. Can you feel? Please touch and see. Yes. When you feel here, you can see feel the vibration on your throat when you are talking. So that is called as vibration. So what is vibration? Fast oscillation is vibration. One more example we have in our textbook. If you were in school, you could have done it together. But because now you are not in school, you cannot feel it. So teachers giving a simple change to that experiment. Okay. Now here I have something called this. This is called as a tuning fork. This is a tuning fork. Now if I beat it somewhere and keep it on my hand like this, I can feel the vibration of this tuning fork. Now because you cannot feel it, I am showing you another thing. I have a glass of water here. Now I am exciting the tuning fork and I am keeping it here. You can see water is jumping up, isn't it? That is because the tuning fork is vibrating. Okay? Why? Because the tuning fork is vibrating. Another thing you can, if I keep it near the ear, I can hear the sound. Listen to the sound of the tuning fork. Can you hear? Can you hear the sound? So why is the sound produced? Because the tuning fork is vibrating. It produces sound. Children, now you can see this violin, isn't it? The strings of the violin, the string instruments, that is the violin, guitar, all these produce sound because of vibration. So when they are excited, the strings on the instruments start vibrating and thus they produce sound. So watch this. Two types of movements we learnt, isn't it? One is oscillation and the other one is vibration. So what is oscillation? Oscillation is the to and fro movement of an object about a mean point. And what is vibration? Very fast oscillation is vibration. And we also learnt that the wiper of the car is not free oscillation, it is forced oscillation, that we are making it to do work. So I hope you have understood, children. Thank you very much.